And so for a strong acid, is this number high or low? Is Q high or low? Strong acid, full dissociation. Reaction goes all the way to the right, right? So this is high. High. This is low. So Q is going to be high for a strong acid, right? Lots of acid dissociates. And so will the equilibrium constant be high or low? High, right? So when this reaction is in equilibrium, you have mostly products and few reactants. And so if I ask you, if I say we have a high concentration of products and a small concentration of reactants, is the equilibrium constant high or low? You should be able to tell me how those relate.
So
yeah.
The products are more favored in this reaction.
Products are more favored in this reaction. KEQ is high. So if KEQ is high, what is delta G? If I have high equilibrium constant, how does that relate to my delta G? Large negative, right? Negative delta G tells you that the reaction is very favorable. And if the reaction is very favorable, that means it's going to move to the product. So high equilibrium constant, large negative delta G. If I have a low equilibrium constant, so if K dissolution is low, is the equilibrium constant high or low? Low, right? K dissolution, K equilibrium, same thing. Is the equilibrium constant ever negative? No. So what's the delta G? So if K dissolution is small, delta G is what? High, low, negative, positive? Positive. And it's probably high, high-ish positive, right? So the more positive that delta G gets, the smaller and smaller the equilibrium constant gets. How do I know that? Delta G0 is, so delta G is delta G0 plus RT ln Q. And so I can relate my delta G0 so I can come up with a relationship between KEQ and delta G0. So I know how my equilibrium constant is going to change in relation to my delta G0 under standard conditions. And we also have this handy table . We also have this handy table, if you remember this, these notes right here, where I have KEQ here, or K dissolution, and I have delta G0. And so these are high numbers, and these are very, very small equilibrium constants. Versus if I have large equilibrium constants, I have large negative delta G's. So if I have a low equilibrium constant, is the reaction thermodynamically favored to go to completion? No. You know about delta G, we always said that a positive delta G is a thermodynamically unfavorable reaction. A negative delta G is a thermodynamically favorable reaction. And so same goes for KEQ. When KEQ is very small, the reaction is not thermodynamically favored. If the KEQ is very large, that tells you that the reaction is thermodynamically favored, and so you're going to have more products. So make sure you know how the concentration of products relates to the concentration of reactants through Q. Make sure you know how Q is related to KEQ. And make sure that you can relate KEQ to delta G. That's going to be a very important relationship on this one. Yes?
Can you number 5 on exam 1?
Sure. On exam 1? Five. Oh, circle the structure with the greater dipole moment. So what is the dipole moment? The dipole moment is... Whoop, whoop. Dipole moment equals strength, or let's say charge, times distance. So if we have, let's see, we have lithium, which is plus, fluorine, which is minus, lithium, which is plus, versus chloride, which is minus, and I said this is 1.2, this is 1.2. So these have the same distance, right? Which one has the higher charge separation?
The one with fluorine.
The one with fluorine, right? Because this one is more electronegative than this one. So this has the higher dipole moment. Which one has the stronger van der Waals forces? The one with fluorine, because it's got a greater dipole moment, right?
LICL is more
LICL is more
polarizable.
polarizable, so it's a toss-up in some ways. So I probably won't ask you something that's a toss-up like that. But this one definitely has a higher dipole moment, for sure.
What do you mean by it's a toss-up?
Well, you need to know to what extent. You know, how important is the polarizability versus how important is the dipole. And the dipole often wins because dipole-dipole forces are stronger than London dispersion forces. So it depends on exactly the balance between the two. But if I asked you, say I said something like this, what if I made them both lithium fluoride? However, this one has a magic bond angle that's 1.6 angstroms, and this has a magic bond distance of 1.2 angstroms. Which one's got the higher dipole moment now? Right one. Larger distance, right? Yeah?
11B from the first one.
11B.
That's the second one.
Yeah, please give a numerical estimate for the equilibrium constant. Okay, so this is a sparingly soluble salt. So let's see, so this is actually solid. This is aqueous. So what's the Q? What's the Q for that reaction? This is the Q, and it's sparingly soluble, so it's going to be a small number, 1 times 10 to the minus 6.
Thanks, Professor.
Yeah. Does Q have any units? No. Does K have any units? KEQ? No. So this is it. So we just need to solve for the concentration of the ions. So the concentration of Ca2 plus is what? Yeah, it's basically a square root of 1 times 10 to the minus 6, right? How do I know that? these concentrations have to be the same. 1 calcium carbonate goes to 1 calcium plus 1 carbonate, right? So I know that in this reaction, so the reaction is CaCO3 solid, 2 plus, 2 minus. So I know when I take one of these, I get one of these and one of these. And so I know that these concentrations need to be the same. So this is x squared. So I'm solving for x. X equals square root 1 times 10 to the minus 6. So the concentration of the calcium is 1 times 10 to the minus 6. The square root of 1 times 10 to the minus 6.
So you always the element to be equals to x. Like if you have Ca2 plus squared would be x squared.
Yeah. So if this was squared, right? If this is a 2 in front of here or something like that, then this would be x cubed or whatever it is. Okay. So you need to compute the cube and then just let one of your concentrations be the x. Yeah. Or this, if you've got a 2 there, you would have 1/2. This concentration is 1/2 of x, right? Because if you make x of that, you're only going to get half of this. So you need to take care of both the coefficients and the exponents. But that gets tricky. It'll probably only be like a 1-to-1, like I've shown here. Any final questions? Okay, you guys know what time the exam is? 12 something on Tuesday. I have to look it up on Tuesday morning. So I'll see you then.